Hello folks, in this video we will discuss about an incredibly important library in Python, NumPy, which is used for mathematical calculations. So we will use Jupyter Notebook to test NumPy. So to get Jupyter Notebook, you can go to Anaconda and download Anaconda. Then you will get an Anaconda prompt, and here you can go inside any folder and write Jupyter Notebook, and you will get this in the browser. And now we will start writing our NumPy code. So we will import NumPy as NumPy. And what will happen is we don't have to use a long form NumPy. And you can also check the documentations. This is the official NumPy website, and you can see how we can install NumPy and how we can start using. So let's see by writing code. So let's say I want to create an array. An array in Python is something that you can only create using NumPy. You cannot create array in general. You can create lists, sets, and tuples. So I will write np.array, and here in square brackets let me write something 1 2 4 8 10, and let me simply print out my array, and we get these things. We can also print out the type of array, and we get that this is NumPy, this is an array. Now we can also create a 2D array, so let's name it as matrix, and we will simply write np array, and here how we can create a 2D array. So we will use nested square brackets. So let me write 1 2 3, then 4 5 7, and then 9 10 15. This should be commas and not dots. And now we can simply print out the matrix, and we are getting this 2D array. So this is how we can create arrays in general, and now we will see how we can do array operations. So, and we will also compare arrays with lists. So let's say we have two arrays. So I will simply copy this array, and we have one array. Let's name it array 1, and this is, let's say, the same as the original array, and we will create an array 2, and let's change the numbers. Let's make it 2 24 5 18, and let's say 100. Now what I can do is I can simply print out array of 1 plus array of 2, and what do I get? As we can see, the numbers are added, and we can also do other operations like array of 1 minus, let's say, array of 2, and let's do a few more operations like for multiplication, and also let's say for division, and let's say also for the modulus, and let's see what we get. So as you can see, these things are correctly added and deleted. Let's make the bigger one first. Let's make the bigger one as array 1, and now let's see if the results are correct. So 2 minus 1 is 1, 24 minus 2 is 22, and all of these things look correct. And modulus 0 0 1, yeah, you can check it out, but these things look correct. So we can do array operations like this. Now compared to arrays, let's say we have two lists. So let's make it list 1 and one list 2, list 2, and we will simply copy the lists. We also declare lists using square brackets. And now when I do the same thing, first of all let's simply print out the addition, list 1 plus list 2. So as you can see, the lists are just getting added side by side. It's not doing any mathematical calculation, which is doing in case of arrays. So this is a basic difference between lists and arrays. And if you try to do the minus and other things, it will give me weird results or errors. So if I do minus, and as you can see, we are getting an error because these are lists. It doesn't know what a minus is. So that is the basic difference between lists and arrays, and using arrays we can do mathematical operations like this, and we can also do other operations. So let's say we have this array 1 and 2, and let's say what we want to do is we want to print out, let's say, the square root. So I can simply write sqrt. I have to write np sqrt because square root is also a function that is coming from NumPy. And here I will put my array of, let's say, 1. Now if I print it out, and as I can see, we get some points, and let's see if these things are correct or not. So let me just create another array. Let's call it array of 3, let's create here only. We have an array of 3, and this will be NP array, and let's only use square numbers: 4, 9, 30, 36, 100, and let's say 625. Now if I print out array of 3, what do we get? We get 2, 3, 6, 10, 25, which is correct, and this is doing this operation correctly. And yeah, that's it, how we can use NumPy for doing not only these square roots or these additions. We can do many other things. So you can check those things out in the official documentation depending on the project you are building. But here we will move forward and we will check how we can do like reshaping and transposing of arrays. So I will create another array. Let's name it matrix1, but this will be a 1D array, and then we will reshape it to 2D. So let me just write np array, and here let me create an array 1, 2, 3, 4, 10, 15, 20, 100. So we have 8 numbers over here, and now I want to reshape this array. So let me create another variable. This will be an array. Let's call it reshape matrix1, and here what I'll write is I'll write matrix1 comma reshape. And what is the shape I want to give this array? Let's say I want to give this array the shape of 4, 2. Now if I print reshape 1, let me first print matrix 1, and then I want to print reshape matrix 1. And what do we get? So as you can see, the first one is a 1D array and the second one is a 2D array with dimensions 2, 4. So this is how we are reshaping the array. So after 2, the 3 is going to the next line, then 4, 5. We can also make it 2, 4. And you have already guessed the result, and it will look like this. So yeah, this is how we can do reshape. Now we will see how we can do transpose. So transpose is a mathematical operation, and we have to transpose a matrix with some correct dimensions. So let me just create another matrix 2, and this will be a 2D array, and let's make it 1, 2, 3, and then this one let's make it 3, 2, then 4, 5, 7. Now I want to transpose it, and I can only transpose it to 2, 3. So let me write another variable transpose matrix 2, and this will I will simply write matrix 2 comma t dot t, and now let me just print out these two matrices, matrix 2, and then print out my transpose matrix 2, and let's see what we get. So first one is 3, 2, and second one is 2, 3. So this is how we are doing transpose. So if I make it, let's say something else, 4, 2, the transpose will be happening accordingly. I can also make it 4, 3, and let's write 10, 15, 20, 200, and accordingly we will get. So the transpose is happening accordingly, and so this is how transpose works. Now we will see how we can use some functions in my NumPy arrays. So let me just create another array. I'm writing this as matrix, but this is also a 1D array, and let's write something 1, 2, 3, 4, 5. I cannot be more creative. And now what I want to do, let's say I want to print the sum of all these numbers, so I can simply do print, and then I will do np of sum, and I will pass this matrix 3, and we get 21 because the sum of 1 to 6 is 21. Now let's say instead of sum I want to get the mean, so I can simply do np mean and matrix 3, and what do we get? We get 3.5. And let's say I want to get the max or mean, I can do simply np max and then matrix 3, or I can also do np min, so I'll get 6 and 1. So similarly there are like lots of functions we can use in with my NumPy, and accordingly we can write all of these things. So now we will see like how we can access some values inside this matrices. So we have matrix 3 already. So if I write, let's say matrix 3 and then inside square brackets 1, what do we get? As you can see, we are getting 2. If I make it 0, I'll get 1. So these are the indices, and we can accordingly access these variables. And I'm sure we had matrix 2, which is a 2D matrix. So let me just copy this thing and let's make it matrix 4, and we will see how we can get these values for 2D matrices also. So we have matrix 4 right now. Now let me delete this line. And how can we get some values in matrix 4? So I have matrix 4. If I write 0, I'm getting the first row. Now if I write 0, 1, I'm getting number 2, which is the second element of the first row. I can make it 0, 0, and I'm getting 1. So if I simply print out matrix 4 for simplicity, you will get like which numbers we are getting. So we are getting 1, and then if I make it, let's say 3, 3, I'll get, okay, some issue with 3, 3, because this 3 is not present. So first one is 0, 0, and then it is moving forward like 1, 2, 3. If I make it 0, 3, I'll get 6, and now if I make it 2, 3, I'll get 200. So this is how we can access like different values over here. And what about if I simply write, let's first check for matrix 3, that is 1D. Let's say I want to print out print matrix 3, and here instead of writing any number, let me simply write colon of 2, and what do we get? We get only 1 and 2, and that is only the first two values. If I make it, let's say 5, what do we get? We get up to 5. What about 1? We get only 1. Now if I do the same thing for matrix 4, what do we get? So let's copy this line and let's make matrix 4, and we get only the first row. If I make it 2, we get the second row. And can I use comma here? Second row, and then let's say 1. And as you can see, something very interesting. So what exactly is happening over here? So let me just comment out the other lines to better understand. So we are getting 2 and 5. So what is happening is, this one is saying get the first 2 rows, and this one is saying get the first 2 rows with the index of 1. So the first row in the first index we have 2, so we are getting 2. And in the second row in the first index we have 5, so we are getting 5. So if I make it 0, I'll get 1 and 4, and that is what we are getting. So this is how we can also use these colons. And let's say I want to write something like this, matrix 4, and then if I write -1, what do I get? I get the last row. And if I write -2, let's say, what do I get? I get the second last row. So you can also count from backwards, and we will be getting the our elements from the end. So that's all about NumPy I wanted to discuss in this video. So this is like the very basics, the tip of the iceberg. But if you are doing a more complex project, you can always refer to the official documentation and check out for the functions that you need to use. So yeah, that's it for this video. Thanks for watching. Bye bye.